7. Did methane hydrates ever release much methane in history? Pockmarks up to 11 kilometers, 6.8 miles, wide off the coast of New Zealand indicate that large abrupt emissions from methane hydrates did occur in the past. https://methane-hydrates.blogspot.com/2013/c-of-okotsk.html. Since the location of these pockmarks is prone to earthquakes, seismic activity may have contributed to the release. Similarly, seismic activity could trigger large methane releases today. The situation is particularly dangerous in the Arctic. Warnings about this have been published for more than a decade, e.g. see the poster at the bottom of https://arctic-news.blogspot.com/p/seismic-activity.html. In the past, hydrates did likely become destabilized as Earth became warmer during interglacial periods. But while Earth during such periods may have been several degrees warmer than today, warming in the Arctic probably was not as amplified as it is today. In the Eemian period, for example, there were no ice-free summers in the Arctic. Ice sheets remained largely frozen, in part because ocean currents were quite different from the situation today. http://physics.org/news/2012-06-climate-cold-arctic-eemian.html. Similarly, another study found that the Greenland ice sheets experienced only modest melting in the Eemian period. http://www.nature.com/nature/journal/v493/n743/full/nature11789.html. The extensive sea level rise that occurred during the Eemian period therefore must have been due to melting in Antarctica. http://www.nature.com/news/greenland-defied-ancient-warming-1.12265. This suggests that the Arctic sea ice did not retreat enough to cause melting permafrost to destabilize many hydrates in the Eemian period. According to Paul Beckwith of the University of Ottawa Laboratory for Paleoclimatology and Climatology, this can be explained by a number of factors. The key distinction is that the warming today is from greenhouse gases being higher and occurs 24/7, namely the cooling at night is much less, diurnal variation smaller. In the Eemian the tilt of the Earth was much greater, so there was much more seasonality, thus winters were much colder, so the sea ice extent, thickness, and thus volume could build up much more, and the summers were warmer in the daytime. However, the cooling at night was much greater than now, less greenhouse gas, GHG, more diurnal variation. Net result is that the ice was much more durable in the Eemian. Greenland temps were higher during the daytime, but cooled off much more during the nighttime in the lower GHG concentration world. Even where large amounts of methane did get released from hydrates, this may not have left a mark in ice cores. Paul Beckwith explains. The length of time for the methane pulse is very important here. If most of the methane came out in a decade, for example, then within a subsequent decade or so most of the methane will have been broken down to CO2 and H20 and also been dispersed/distributed around the planet, away from the pulse source area in the Arctic. The CO2 produced would have been small, CO2 stayed within 180 to 280 ppm range. It takes about 50 years or even more, depending on the snowfall rate and surface melt rates, for snow at the surface to be compacted into firn that closes off the air spaces, creating the bubbles in the ice that are reservoirs of the methane and other atmospheric gases. Because of that 50-year bubble closure time, the large pulse of methane that was burped out of the marine sediments and terrestrial permafrost would be long gone and not result in a detectable signal in the ice core record. Just because the record does not capture it does not mean that it was not produced. The above points were mentioned in a post by Nafiz Ahmed at The Guardian, at http://www.theguardian.com/environment/earth-insight/2013/august/05/7-facts-need-to-no-arctic-methane-time-bomb. Furthermore, methane that did get Furthermore, methane that did get trapped in ice may have returned to the atmosphere as temperature rose and the ice melted. Higher temperatures for thousands of years ensured that the methane was over time oxidized, leaving only carbon dioxide traces in later ice, and thus in the ice cores that we examine today. For more on this point, also see the comments and responses at https://arctic-news.blogspot.com/2013/07/arctic-methane-release-economic-time-bomb.html. So, many large releases of methane that occurred in the past may not show up as such in records such as ice cores, but large abrupt emissions from Arctic methane hydrates did likely play a key role in the sudden massive warming 11,600 years ago at the end of the Younger Dryas Cold period, according to http://www.sciencemag.org/content/324/5926/477.summary. There is also evidence that large methane releases to the atmosphere from deep-sea gas hydrate dissociation occurred during the last glacial episode off the coast of Papua New Guinea, 39,000 and 55,000 years ago, as well as in the Santa Barbara Basin, which occurred in response to a warming of the intermediate waters and thus presumably of the deep-sea sediments. These deep-sea methane emissions occurred synchronously with rapid climate warmings associated with atmospheric methane increases and led Kennett et al. To propose the Clathrate-Gunn hypothesis, which postulates that deep-sea methane hydrates played a significant role in late Quaternary climate changes. http://www.pnas.org/content/101/25/9187.full http://www.sciencemag.org/content/288/5463/128.abstract http://www.agu.org/books/sp/v054. In conclusion, there's no reason to doubt that there have been large emissions from methane hydrates in the past. Furthermore, the current situation is unprecedented and looks more dangerous in many ways than in previous periods. Firstly, the rate at which temperatures are rising, particularly in the Arctic, is without precedent. Furthermore, the levels of pollutants in the atmosphere today are extremely high, and rising, which is the more dangerous given the presence of huge amounts of methane in the shallow seas of the Arctic. For further reasons why the current situation in the Arctic is so dangerous, see point 8 below and Methane Hydrates, by Sam Carana.